So in the final part of this tutorial, we will show how we can use a recent state-of-the-art model to do the same task we did before for our multi-layer perceptron, and we will also highlight how it can achieve a substantially higher F1 score. So let's start implementing or fine-tuning our BERT model. Since the BERT model is actually capable of generating contextualized embeddings, this time when reading a document we will try to model its internal structure. So to give the model an idea of what a whole document is and basically where the separator tokens should be set. So we modify our method for reading documents a little bit. So we basically add another routine where we check for lines and add them in a nested list. Now next we again define our labels, and for the pre-trained model we will use a German BERT model that has been provided by DBMZ. Okay, so what we need to do when dealing with subword tokens is basically we need to tell the model that some of the words are actually subwords and hence are not really contributing something towards the error. And how it's done in PyTorch is basically you can assign them with a special label that will tell the model that when you compute the loss, you can ignore the subword token. This is basically what we are doing here. And after doing that, we can then encode the labels and the whole data basically. And we then implement our data set. So now we are ready to write our training routine. Again, we will load the pre-trained model specifically for token classification, which is a class implemented by Hugging Face that lets you do classification on the individual tokens, basically. So what we are doing, we define our data loader. We use the same parameters as we used for the multi-layer perceptron. Define our optimizer and write our training routine. One thing that needs to be told is that since transformers are only capable of handling a fixed size of inputs, not everything is basically needed. So sentences that are, for instance, too short will be padded with additional tokens, and we need basically the attention mask to tell the model which tokens to look at and which to ignore. Same will go, for instance, for the CLS token when we do the token classification. And after training, we do our prediction again. Here we need to keep in mind that -100 basically marks the labels of the tokens that we want to ignore. And this is basically what we will do here when computing the F1 score. We will first filter out all the instances that we can ignore. So basically which are padded or are subwords that we do not want to use. And as in the previous tutorial, I put everything in a Python script, clean up some of the imports. So this is basically exactly the same as in the Jupyter notebook, and then train our model locally. As you can see in the final test score, we definitely improve over the previous multi-layer perceptron. However, note that all the data we use is really informal, and hence it is not that easy actually even for newer models. What we can see is still a substantial improvement from 0.05 to 0.22. And during training, what you can see is sometimes the model loss decreases and then starts to increase again. And this leads me to a couple of final remarks. So What we basically did here in this tutorial, we did not use a development set to tune parameters or select the correct model. What you often do is you additionally split your training data into a training and development set, which basically means after each epoch you use the development set to evaluate your model and try to decide which model from which epoch to choose. So basically, in this example, you would, for instance, instead of selecting the last model from the final epoch, select the model from the 15th epoch. Alright, thank you for watching, and if you have any questions, please feel free to leave us a message. Thank you.